Morning, Hayden. Morning, Ezra. Hi, Ryan. Hi, Downey. Hi, Eric. So today there is nothing in the due soon. If I zoomed out, look over to the left, no upcoming work. That's partially true. There's no large assignments, but we are going to be watching Bill Nye together on the stream, and then completing a form of a few questions that just coincide with the episode on outer space to kind of transition from talking about just the sun, the earth, and the moon to the entire solar system now, and even beyond that in the future. What's beyond our solar system? What's beyond our galaxy? All right. So, just quick note about the test. We'll watch Bill Nye. I'll pause here and there because those of you on stream probably did pretty well on the test. I've looked at a couple of yours. I've looked at the first 59 who turned it in yesterday. Those of you who were on stream regularly or in chat regularly, I'm off the top of my head assuming you did really good. So, kind of as a reward for that, I'll go through the form with you with the episode so you guys are still on top of things. All right. So, the form is linked down here. All right. And then the episode is actually inside the form if anybody's absent or if you want to watch it again, it's right there. All right. The questions are all multiple choice. Most of them are very straightforward if you just pay attention to the episode. So that as long as you're paying attention, you'll do fine. All right. Again, it's just a transition going from the sun, earth, moon to our solar system. Any questions? We'll find out officially soon, Eric. So about the test itself, I've, like I said, graded the first about 60. Hello, Rainy. Hello, John. Tests that were turned in yesterday. I still have another, based on how many turned in, I probably got like another like 15 to 20 left to grade. Then I have to track down those who decide to hide out online and not do the test. So I'm hoping that your score is in Aspen really soon. So probably looking at like, I don't know, Thursday or Friday when you're not in school. All right, there's nothing new. So you can check Aspen then. Um, I'm being lenient on the justification so that as long as you're doing well in the multiple choice, you should be doing well overall in the test, as long as you are showing logic that we've used in class. All right. Questions on that? No? All right. Bill Nye, and then let's take a look at the form. Form first, just kind of get an idea of what we're going to look for. Outer space, is it so big or so small? Some of these you could probably answer kind of logically if you have a background. You like space. All right. Side note, by the way, too, my wife found this app, Night Sky, on iOS. I don't know if there's an Android version, but it allows you to take a look at your location and you can point your phone anywhere in the sky, even during the day. And it'll tell you what you're looking at from major planets, galaxies, satellites, dwarf planets. It's pretty cool. So, kind of getting into the future of what we're going to be talking about, maybe at nighttime, you download Night Sky. It's free. Don't do the premium option, and then you can kind of look at the night sky, what we're talking about, in the next couple weeks. All right. So outer space, it's so big. Is everything close? Everything far away? Have we learned everything about outer space? The Earth and the Sun in space on a human scale are very far apart. They're very close together. All right. So just some things to think about. We're talking about size and scale here in the first few questions. All right. Star Walk 2, Kim. I'll take a look at it. If the audio is a little loud or you can't hear it, let me know.
Man, it's big. There's a lot of it. And a lot in it. Outer space. Man, it's big. There's a lot of it. And a lot in it. You know, most of what we've learned about outer space, we've learned the same way that people have been learning about it for centuries. By looking up in the sky and going, whoa.
Whoa. Wow.
So right in there, he's at an observatory where there's a very large telescope pointing out to the sky. And what that telescope does is it takes in light, collects it over a longer period of time, focuses it. It's like leaving your camera shutter open for a while. All right, except now you're pointing at a star, not at a person. So instead of getting all blurry, you'll see more detail of a star as it gains more light inside the telescope, or planet, or whatever you want to look at.
Whoa.
Whoa.
Whoa. Hey, take a look. Careful of your eye, you goofball. Kids.
That is an old
Man,
telescope.
it's big, isn't it? Hey, what's that? Whoa.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill.
Hi, Charlie.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill. Science Guy.
Oh, where is it?
Inertia is a property.
Nice linear scale of the solar system. A little inaccurate, but this one right here. Bill's showing his age, being made in the 90s right there.
Of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Twinkle, twinkle, little star, how I wonder what you are. Up above. Oh, hi, I was just,
Uh-huh.
Well, anyway, outer space is so big, and everything in it is so far away. Do you know how we know? Well, we'll just look. By looking at the stars, we've learned about outer space. And do you know what else? Everything out there is made of the same stuff that we are. Isn't that wild? So, come with me today while we explore the vast, wonderful world of outer space. Outer space is big. We have to go out. Way out. Outer space. Way out here. Whoa. Things in space are very far apart.
What do you mean?
I mean, very far apart.
Uh-huh.
Let's say that this little ball is the Earth.
All right.
Here comes
this
some
little
models.
ball. And you and I are right here at Nye Laboratories. How far away do you think the sun would be? Would it be this far away? This far away?
I don't know.
Maybe this far away?
Maybe.
No. Watch. Would be this far away.
Whoa.
20 meters. That's right.
So almost 2 rooms away for that tiny blue dot, and the sun is about, I don't know, cross between a softball and I don't know, a little larger than a softball. I don't know what kind of size you can call that. All right. Go back to the form quick. Outer space is so blank, and everything in it is so blank. He's already said that. All right. How have we learned about outer space? We looked or tried to look through a observatory. So what would you be doing at an observatory? And the third one, the Earth and Sun in space on a human scale now. All right, we try to scale it down to two objects really small, and it was almost 2 full rooms apart. So in terms of human scale, what are the Earth and the Sun? All right. Looking at the next couple questions, we're looking at how we use light to measure these large distances. Okay. While you're answering those and coming back, I figure we're going to need our resident astronomer. Oops. Dr. Carl Sagan. Famous astronomer in the 80s and the 90s. Responsible for making astronomy very accessible. Who'll watch it with us? Yeah, Rainey. Yep. Tell Paulie that Sagan is joining to join us.
If the Earth were this big, the Sun would be this big, and they'd be that far apart. Now, what about the planets and other stars and galaxies?
I don't know.
Well, they're really far apart. I mean, they're way out there.
Our Earth is big, and so is our solar system, sure. But look at the sky at night. Some of those points of light aren't stars. No, they're groups of billions of stars. But they look like a single point of light because they're so far away. Whoa.
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 Whoa. Whoa.
Whoa.
How long do you think
Whoa.
it would take me to get from here to where you are? Well, let's see. Here I come. Took about a second, right? How long do you think it would
got a
take
fast
the
40.
fastest thing in the universe to get from here down there? How long? Well, a lot less than a second, I'll tell you. Here's the fastest thing in the universe. It's light. Light goes 300,000 kilometers every second.
300,000
Not
kilometers.
300,000 kilometers a minute, but 300,000 kilometers a second.
So you're used to light being instantaneous. You turn the switch on, light fills up the room. You turn the flashlight on your phone, it hits whatever surface you're pointing it at. Almost immediately. Basically immediately. Why? Because the distance in the room or on the phone to whatever you're pointing it at is so small, light reaches there incredibly fast. Light does have a speed limit. All right, what he's giving you is the speed of light in a vacuum, so empty space. We're not talking air, not talking water, not talking going through glass, not talking about bouncing off walls. We're talking about going through empty space. So in empty space, without interfering, without any molecules, compounds, or anything else, then it's going to go 300,000 kilometers a second. So I'd check your form if I were you.
Things in the universe, things like stars and galaxies, the things in the universe are so far apart that it can take even the fastest thing there is. It can take even light millions and billions of years to get from one place to another.
And that's the big issue with space, is it's so incredibly big, and even though light travels so incredibly fast to humans, light can't cover the distance in a short amount of time. It takes a long time for light to get from one place to another. For example, it's going to take 8 minutes from the light of the sun to reach the Earth. So if the sun all of a sudden just disappeared, I wouldn't say exploded, because then you wouldn't be here. But if the sun disappeared, you wouldn't know for 8 minutes.
Even at the speed of light, which is pretty fast.
So what you're saying, Bill, is the closest star to our sun is 4.3 light years away?
That's right. Now, a light year is the distance that light travels in a year. Now, light goes pretty fast, and a year is a long time. So a light year is really far. 9.5 trillion kilometers.
Wow. So that means some of the stars we can see right now may not even exist anymore?
That's right, that's right. Maybe a star is burned out and collapsed. Okay, well then it stops giving off light. Well, the light keeps coming here for years. So, in a way, the star doesn't burn out and collapse here until the light stops coming here. Whoa.
Did you know that?
The Great Red Spot on Jupiter is actually a hurricane larger than the Earth.
Now you know.
And it's actually going to disappear in the next decade or so. So, back to the form. What is the fastest thing in the universe? Is it comets? Is it black holes? Is it galaxies? Or is it light? So what is the fastest thing? If you got a question, let me know. I'd mark it if you think that's what it is. Light travels at the speed of what? Ooh, got a little tough on you. I just gave all threes and zeros. 300,000 kilometers an hour, 300,000 miles per hour, 300,000 kilometers per second, and then 3 million kilometers per second. What's the speed of light? I'm more or less asking, were you paying attention to those units he said? All right? Were you paying attention to those units? And then were you paying attention to the number itself? All right? A couple of you seem to be on the right track. All right? Especially that S part, right, Ryan? That's what I'm kind of checking to make sure you know the difference between the first and the second options. All right? The closest star to our sun, Proxima Centauri, is how many things away? 4.3 was what we said, or what was said in the video. So I said 8 light minutes was for the sun to reach the Earth. So out of option A, B, and C, 4.3, is it light years, light meters, or light minutes? What is the unit of time that we use, or unit of measure of distance in space? Because space is so large, how do we use light? Okay? And then what actually is that unit up above? A what? A what is the distance light travels in a year? Hopefully you can answer that one, just based on logic. Distance, light travels in a year, light in a year, light in a year. This makes no science. It's a good one. It's worthy of Bill Nye himself. This right here, in case you're interested, I know there's a couple Star Wars fans listening. Parsec, not a unit of time. So if you make the Kessel run in parsecs, that's wrong. I know you probably already know that. But it is a unit of angle in the galaxy, actually. You're a bit late, Jack. Well, we've been watching the first quarter of Bill Nye, kind of answering the questions as we go. You can catch up by looking at the link I posted in Classroom, or the form I posted in Classroom. Answer a question on Remind. All right. Fastest hunk of junk in the galaxy.
How far is far? On Earth,
Yeah, Eric,
far
I like
may
your
be
dad
to the other
joke.
side of this lake, or across the city, or across the country. But in space, the sun and moons and planets of our solar system are only tiny dots in the galaxy. And the galaxy is only a tiny dot in the universe. You know, you couldn't get to the nearest star that's our neighbor, even if you spent your whole life traveling. But I digress. The thing to remember is, things in space are really far apart. Whoa. Oh, man. Imagining distances in space is difficult because everything is so far apart. But think of it this way. Let's say that this miniature soccer ball is
So
the
another
size
model
of our
this time.
sun, and it's right on the goal of a soccer field. Then this speck is Mercury. This is Venus. This tip of a ballpoint pen is our Earth, 2.5 meters from the miniature soccer ball sun. Mars, Jupiter, Saturn, 25 meters from the goal. Uranus, and Neptune, 76 meters away. And Pluto's back here, almost out of the building, 100 meters away.
Just a reminder, though, a lot of diagrams draw the planets in a line. That is incredibly, incredibly rare to have in a planetary alignment of all the 8 objects, the 8 major planets. You're going to see most often planets scattered in their different orbits. They'll be orbiting around the sun counterclockwise at different distances from the sun, but at different locations in their orbit. All right. Pluto, not a planet anymore. At the time of filming, Pluto was still a planet. Then it was demoted in 2006. I think right before you guys. I don't know what year you guys were born in. Most of you 13. So kind of right before you were born. Making me feel old. Pluto was demoted to a dwarf planet. It was the first of the dwarf planets that were later classified in the Kuiper Belt. Kuiper Belt is the area past Neptune. Okay?
And Neptune, 76 meters away. And Pluto's back here, almost out of the building, 100 meters away. How far do you think it is to the next star? Well, it's not in here.
Next town.
Kids, don't drive this way at home. You could leave tire marks on the living room carpet.
Boy, I hope I unplugged the iron. Hope I didn't leave the stove on. It would be here. The nearest star would be here. 7 hours of highway driving, about 700 kilometers away.
Oh, a
And
little
that's
longer
only
than the
thinking
next
of
town
the
over.
stars being this big. I mean, real stars are huge, enormously huge,
Right.
enormously, bigly huge.
All right already.
Nothing like this. You couldn't get to the nearest star if you traveled your entire lifetime. No way. It's kind of cold out here. Have you ever heard of the Big Dipper? The Big Dipper is a constellation. Now, a constellation is a group of stars that we've given a name to help us find certain stars or recognize them. Now, ancient Greek and Roman astronomers...
So, constellations, he says the Big Dipper. Big Dipper is not actually a constellation. It's a group of stars that are in the constellation Ursa Major, the Big Bear. The Little Dipper also isn't a constellation. It's part of a group of stars that look like another constellation, but they're part of the major constellation Ursa Minor, the Little Bear. Okay, so constellations, grouping of stars that ancient Greek and Roman astronomers observed and named. All right, the one that we're going to look at most in the next couple weeks, I'll use as an example, is Orion, which is actually setting now in the wintertime. Comes up in about the southwest and then sets after a couple hours at night. Easy to spot though because you can find those 3 stars of the belt. All right. Also, you can find one of the brightest stars in the night sky, Sirius, if you look backwards, diagonal to the south from the belt. So you trace a line from the belt and then you go backwards, due south, and you'll find Sirius. And then that is another star, part of another constellation, but you can find the other constellations too if you use that Night Sky app. Or I know Kim put one out there, which was Skywalk or Starwalk. I gotta check again. back in chat and then look it up later.
Gave all sorts of constellations names, and we still use a lot of those names today. Like Orion the Hunter, Cassiopeia the Queen. And Greek and Roman astronomers gave all sorts of constellations names, and we still use a lot of those names today. Like Orion the Hunter.
I don't get this one. I never have gotten this one. I don't know how this W, this squiggle, is supposed to be a queen on a throne. Ancient Greek queen on a throne,
Cassiopeia the
Cassiopeia.
Queen.
Don't get it. However, you can use this star right here in Cassiopeia, I don't know its name, and you use it to point to the galaxy Andromeda. Cassiopeia is not this close to Orion in real life. Cassiopeia right now is in the northeast when it's starting to get dark, all right? And the Andromeda galaxy is over here in this corner. Very hard to see unless you have really good binoculars or a small telescope.
And the Big Dipper. You know, I don't think the Big Dipper was an ancient Greek or Roman name.
We talked about Polaris. What is it? What's its common name? Earth-Sun geometry. I don't know which Cole you are. Are you Sean or are you Autumn? Polaris has a... there you go, North Star. Thank you. Can I just take a look again at some of these questions? Making sure we're 5G bucks. Get out of here. A light year is equal to how many kilometers now? It's about 6 trillion miles, but how many kilometers would it be? He said 9.5, but is it million, billion, trillion, or quadrillion? All right. North Star, yeah, got it, Kim, Ryan. Some stars we see now may not even exist anymore. Oh, really? I wonder why that would work. I wonder if he's going to explain it.
If you live in the northern hemisphere, the northern half of the Earth, like right here is Nye Laboratories, one of the easiest stars in the sky to find is the North Star. Sometimes it's called Polaris, and it's right over the North Pole. So North Star, North Pole, Polaris, you with me? Anyway, the Earth's axis, the imaginary line that the Earth spins around, seems to point right to Polaris. So let's take a look through the window of science. Now, see, Polaris is on the end of the handle of the Little Dipper, and the two stars that form the front of the cup of the Big Dipper make an imaginary line that seems to point right to Polaris.
It's kind of cut off. You can see it. He's saying the two front stars of the Big Dipper point to the North Star, and that's how you can always find the North Star. It's not very bright. I mean, it's easily visible, but it's not something that you're going to look up in the night sky and say, oh, wow, that's the North Star. Use the Big Dipper to find it.
Polaris. Now get a good look at it, because Polaris won't always be our North Star. No, the Earth's axis is wobbling, just like the axis of this top. See how it forms a small circle? The same is true of the Earth's axis. And eventually, it won't be pointing to...
It's always tilted, but that tilt is changing direction. It flips back and forth. It's wobbling, like he's saying.
Polaris, it'll be pointing to another star, to Vega. But that won't be for about, 12,000 years. So I wouldn't wait up for it.
Okay.
So the next North Star would be Vega in about 12,000 years. Vega is one of the brighter stars in the night sky, so it'd be much more easier to find the new North Star. Okay, so light years equal to this. Some stars we may not even see exist anymore. That is true, because if the sun were to blow up or go away, you wouldn't know for 8 minutes. If Proxima Centauri were to blow up, you wouldn't know for 4.3 years, because it's 4.3 light years away. There was a lot of rumor and speculation that Betelgeuse, the armpit of Orion, massive red supergiant, actually the only star we can actually see surface features on because it's close and it's so large. That star, they thought, is they're assuming is going to go supernova relatively soon. Supernova in terms of 10,000, 12,000 years from now. But some people were hoping it was going to happen now because they saw Betelgeuse dim really, really dark. And that would be a sign that a star was going to become supernova. So that did not happen, obviously, and the brightness is returning because what they found out is astronomers determined there was gas ejected or near from Betelgeuse that was kind of obscuring some of the light. All right. Great red spot on Jupiter is actually a what? That was said before. Is it a canyon, a hurricane, an ocean, or a crater? Is there a surface on a gas giant? That is a big question. We'll get to that soon. A couple weeks. You could reach the star closest to the sun if you traveled your entire lifetime. So we lost track a couple of these questions. Could you reach Proxima Centauri 4.3 light years away in your lifetime? 6 trillion miles. So you're looking at like almost 25, 27 trillion miles away. Could you ever reach there in your lifetime? 9.5 kilometers. So you're looking at almost 38 trillion kilometers away. Could you reach there? And then a large group of stars that we have named help us track other star locations and names. Not that we have named, but the people who gave us our society, ancient Greeks, ancient Romans, what are they called? Many Arabic astronomers named some of the individual stars, and we use their names for the individual stars. Not with current tech. Nope. Eric, is this going to be graded? Yeah. Why wouldn't it be? Yeah. Uh-huh. You keep asking, I'll keep saying yeah. What is the name of the North Star? Is it going to be Vega, Betelgeuse, Polaris, or Norris? What is the name of the North Star? Currently. Will Polaris always be our North Star? Guess that kind of, gives it away, huh? Will Polaris always be the North Star? When will Vega be our North Star? What year? How many years from now? 8,000 to 12,000 to 12 million to 8 million years from now. Good question, Hayden. Is there a South Star? No. There is no star that sits right above Antarctica. That's a good question, though. There are constellations that only appear in the southern hemisphere, though. Just like there's constellations that only appear in the northern hemisphere. Like the Dippers. Famous southern hemisphere constellation would be maybe like the Southern Cross. There's no west or east because we rotate west to east. So it's the hemispheres that get differentiated between what stars you can see. Because the stars are in all directions. So you can't see some stars south because the rest of the planet is in your way. Nope, there's no west star. Did you try setting it to Wumbo? Goal of an astronomer. Who is Eratosthenes? And different elements in atoms, where do they come from? That's what we're going to be looking at in the next section. We are a little under halfway there. That is true, Hayden. Yep. So dim we couldn't see it. Dim or far, either way.
Whoa, dude. This is awesome.
Definitely. Awesome. I mean, like all those stars. Dude. Oh, there's millions of them.
Remember, those stars
And like
aren't
each one of
actually
those
moving.
stars
They do
is
move,
like a
but
sun.
Earth
Like,
is rotating.
whoa. Dude, that means that, like, oh, there's tons of other solar systems.
It's not LSD.
Whoa. Yeah.
They like science.
Whoa.
Bad, John.
And that means that
Removed.
we're like little specks. Oh, like almost nothing. Whoa.
People have always used their eyes to study stars and planets. Sometimes they use astrolabes. You can make one. All you need to do is cut out a piece of cardboard so it looks like this. Then take a protractor and mark off every 10th degree. Now draw lines. Now label them.
So an astrolabe allows you to measure the arc distance of stars, measure the location. What he's doing right now is just measuring the degree angle from a protractor.
Then take a straw and tape it on the side. Then take a string that has a washer tied to it and tape it on the other side. There, you're set. Go outside at night and look through the straw and find a star.
Don't use the sun as a
Find out
star.
where the weight hangs on the astrolabe. Come outside a couple of hours later and find the same star. You'll see that it moved. That's because the Earth is turning. Astronomers also use astrolabes to find out the motion of stars and find planets. It's freezing.
So that's a real key thing to look at. The Greek astronomers, ancient Greeks, used the word planet, which means wandering star, to figure out that some of the stars were moving more than the other stars against the background. Right? And then these same objects have been discovered and rediscovered over the centuries, the millennia. Right? The Mayans, the Aztecs, they're measuring and observing stars and planets. The ancient Greeks, ancient Romans, they're observing, measuring stars. The Egyptians, ancient Arabic astronomers in the Middle Ages and a little bit before then, they are using and have invented the astrolabe to be able to measure the distance that those stars are moving in a certain amount of time. But they find out that these stars are moving more than the others, and they're moving across a very thin band across the night sky. So they give the name planet. And so they start identifying certain of these planets based on their appearance with the naked eye. So they're able to pick out Mercury, Venus. They name the other one Mars. Then they can pick out Jupiter, Saturn. Planet 7 and Neptune aren't discovered until kind of near the time frame after the Revolutionary War because they're so far away. Even though they're large gas giants, they are so far away they're hard to see unless you have the technology to see them.
I'm Eric Wilcox, and I'm a staff scientist and astronomer here at the Very Large Array. You know, what astronomers do is to try to figure out what is going on with a variety of objects out in space. What we have here are basically radio dishes, these big, giant, curved dishes which receive radio waves coming from some object out in outer space. We look at planets like Mars and Jupiter and Saturn. We look at stars. We look at galaxies, like our own Milky Way, but beyond our Milky Way. What we do is through a variety of computers is we turn that electronic signal into its image. We can then display that image on our computer screen. So most of the science comes in looking at that screen, looking at the image, and really that's really where we do what astronomers do. The basic idea, and as scientists in general and astronomers in particular, our goal is to understand the universe.
Goal of an astronomer, understand the universe. I'd check your form if I were you. Also, they're using radio waves to map and to study certain objects from a long distance. Radio waves are a form of light. just you don't see them. You think of radio waves as sound because it comes up on the radio, but in fact it's actually light has been stretched very, very long.
Whether or not there is Klingons on the other side of the galaxy, I don't know.
Did you know that?
10 tons of meteorites hit the Earth every day. Most are the size of a grain of sand.
Now you know.
Meteorites.
Sigh.
Oh, these guys again.
Whoa. About 2,000 years ago, in the town of Alexandria, which is here, near the mouth of the Nile River, what is now Egypt, there was a guy named...
Hey, look at that. Indirect light, direct light. Curvature of the Earth. This is going to be about Eratosthenes, the next question.
Eratosthenes. And he was the librarian of the great library of Alexandria. One day, he came across a note from someone who lived here in the town of Sina. And the note said, at noon on the longest day of the year, sticks cast no shadow, and we can see all the way to the bottom of our well.
The sub-solar point.
Eratosthenes realized that where
Direct
he
light.
lived, sticks did cast a shadow, and he couldn't see to the bottom of wells. And he got to thinking about it, and he realized, oh, the Earth must be round. Yeah, we must be living on a big ball. That's the only
spherical,
way for there
not
to be
round.
no shadow here and a shadow here. So he measured the shadow that the stick cast, and then he paid someone to walk from Alexandria to Sina and keep track of the distance as carefully as he could. Well, that distance turned out to be around 800 kilometers, and the shadow was about a 50th of a circle. So then he multiplied 50 times 800, and he got 40,000 kilometers. And
It's
that's
spherical.
the distance around the Earth, what we call the
Round
circumference
could still
of
be
the
flat.
Earth. So check this out. This guy made observations of a star, our sun, and he figured out the size of a planet, our Earth. The same kind of observations that you can make. Hey, not bad.
فعندها طلب أريتوستنيس من راع كان هناك. يا أخ امشي إلى سينا وقس المسافة.
He used early geometry.
هل أنت مجنون؟ قال الراعي. المسافة تكشف لي عن حجم العالم. قال.
His measurement of the circumference of the Earth was incredibly accurate.
وعليه اضطر أريتوستنيس
Not until modern
أن
technology,
يدفع للراعي أجرته
you get something more
مضاعفة.
accurate.
ومضى الراعي في رحلته. إن رجلي متعبتان حتى الموت. قال الراعي.
We are at T-minus 4 minutes and counting. Roger, I'm switching on all 3 fuel cells and main power supply. The launch conditions at Kennedy Space Center are good.
Well, space...
So, kind of review back a little bit. Name of the North Star, it's Polaris. Okay, will it always be the North Star? No, because Vega is going to become our North Star in about how many years? Okay. The goal of an astronomer, he said, was to understand the what. Just the Earth, just the stars, all nature, or all the entire universe. Through observing shadows in 2 different cities, Senna and Alexandria, Eratosthenes discovered that Earth is actually flat, round, spherical, far from the sun. What is the best answer there? There's a couple that are right, but what is the best possible answer? What is the most specific? All right. Different elements and our star and atoms we have not heard yet.
Space camp is really just a place where you learn about space and the planets.
Launch control Columbia. All systems ready and the crew is go for launch.
The most exciting part of the day is when we do our missions.
Columbia, start auxiliary power units. Roger, starting all AP.
We train like a real astronaut would. 8, 7.
Well, we ride simulators to teach us about what it would be like in space.
6, 5, 4.
Okay, in the future, I think a lot more people will go to space. It'll be like a regular thing.
3, 2, 1. Booster ignition. Liftoff. We have liftoff. Columbia.
Space camps still exist.
You learn a lot about space and what it would be like to be an
NASA even puts them on for teachers during the summer too.
We are ready to come home. Houston, the payload is secure and ready for re-entry. Please turn on all 3 fuel cells and switch to all 3 power buttons. Roger, fuel cells and power system on.
I want to be an astronaut.
Yes, I do want to become an astronaut.
I think that it would be like the best experience that there is.
Correct. Have mission specialist 1. Good job, guys.
All right, our sun now.
Welcome back to the Star Cook.
Thank you. Welcome back. I'm Michaela, and I'm here with my very special guest, Mr. Bill Nye.
Thank you, everyone. Michaela, it's so good to be back on the show, and you are looking fabulous.
Thank you. You too.
Some of them probably could have.
So tell me, Bill, what are we going to do today?
We have here the ingredients to make virtually anything.
Oh, these are different kinds of atoms.
That's right. These are all the different elements, all the different kinds of atoms in the universe. Now, atoms come from stars. Now, take, for example, our planet. Our planet has a lot of iron and silicon, along with many other elements. And our star has a lot of
I don't think I have the time now to travel down to Alabama. It'd be fun, though.
Helium. Now, Michael, oh, that's our hydrogen. Almost lost it there. It's okay, everybody. It's okay.
He's got
now,
it.
Michael,
It's okay.
You and I are 65% water.
Right.
Now, what's water?
H2O.
That's right, H2O. I have some water
Good
here,
review of 7th grade.
which I prepared earlier.
Well, of course.
And the water is 2 parts H and 1 part O. H2O, water.
So with this here, we can make virtually anything.
Well, actually, no.
Sort of.
Because in order to make all these atoms, you need the force of exploding stars and billions of years. But brownies, on the other hand, only take about 35 minutes.
And even brownies are made of atoms.
That's right.
Oh, Bill, this looks fabulous. People, it looks fabulous.
He's using a pizza cutter to cut brownies.
Thank you, dear Michael. You please have the first one.
Oh, thank you. Oh, delicious. We'll be right back.
Thank you. Now, people say, why make observations of stars? Why look into space? Are you kidding me? It gives you a perspective.
We're gonna have a Bill Nye
of where
rant.
you are in the universe, of what we do all day. I mean, what are you trying to make some kind of joke? I mean, we are made of the same material as stars. Stars, you, me, the camera, the television you're watching, everything made of the same stuff that stars are made of. So you have to study stars in order to understand what we're made of. For crying out loud.
So back to the form. Different elements and atoms, like he said in his cooking show, they have to come from somewhere. You can't just have matter and mass come from nothing. So light, stars, galaxies, or comets. What's going to actually create the atoms that we use in chemistry? Our star has a lot of what? So what are the elements that our sun, is using? Is it using hydrogen, oxygen, or nitrogen? And then what else? Is it helium or carbon? We talked a little bit earlier in the unit, and we're going to focus more on fusion. You take 1 and 1, you can make 2. And that energy released in the process of fusion is the energy that stars use to produce and to release light, and also prevent themselves from collapsing down into themselves. So the power of fusion, what are we fusing? Is light made up of atoms? So from last year, you should kind of remember, is light matter or is light energy? We think of light as radiation, electromagnetic waves, the electromagnetic spectrum. Is that matter or is that energy? And kind of like how Bill Nye was ranting about, we are made of things from stars. That's almost a direct quote from my guy above me, Carl Sagan. He said that we are made of star stuff.
Whoa.
Oh.
Well, when I looked up at night, well, there's so much I can tell.
We'll skip the song.
Just by me, baby, you're all made.
You know, since the show started, the light coming out of your television set has gone about 540 million kilometers. Now, if it
Since the show has started, since this video started, light from your screen, from whatever you're looking at, has gone. What'd you say, Bill?
You know, since the show started, the light coming out of your television set has gone about 540 million kilometers. Now, if it happens to be headed in the direction of the
540
nearest
million
star, Alpha Centauri,
kilometers.
it's got another 41 trillion kilometers to go. Now, that's
You said Alpha Centauri is our closest star. Used to be, until we found out Alpha Centauri is actually 2 stars in a binary system. Proxima Centauri is the other star and is actually closer to us. Proxima, close.
a long trip at the speed of light. So don't go asking me, are we there yet? Are we there yet? It's going to be at least 4 years, okay?
Not
Well, if you'll
cool,
excuse
Hayden.
me, got some stellar coordinates to record. See you around the solar system.
Produced in association with the National Science Foundation.
So that's the overall episode. If you want to rewatch it yourself, the link is right there at the top of the form. Form is right here in the posting today in Google Classroom. Okay. Yes, the questions are graded because you're taking time to answer them, but it's not going to be a major grade. Outer space is so, what is it, big or small, and everything so closer away. He did answer the last question. If not, we'll get to that in a second. Outer space is so big, everything is so far away. Okay? How have we learned about outer space? Well, you actually have to look at things in order to understand them, right? So by looking and observing, looking out and observing, right? Because most of them are done at observatory, radio, astronomy, radio observatory, okay? Other telescopes, observatories around the planet. The Earth and the Sun in space on a human scale, on a very large distance apart from each other, but they're very close in terms of a cosmic scale. All right. What is the fastest thing in the universe? You can't go faster than the speed of light in a vacuum. Light's speed can change depending on what it travels through. Okay, it'll go slower through water. It'll go a little slower through air because those molecules it bumps into and interacts with. All right. Light travels at a speed of 300,000 kilometers a second. Almost instantaneous when you're talking about here on Earth. The closest star to our sun is 4.3 light years away. That is Proxima Centauri. A light year is distance that light travels in a year. Light in a year. Light year. All right. A light year is equal to, in kilometers, 9.5 trillion kilometers, or if you want to use your imperial units, 6 trillion miles. Some stars we see now may not even exist anymore, and that's true because think of the speed of light as the lag of the universe. It can only process at a certain speed. Okay, things are only seen if they give off light. So there is something called the observable universe and the universe itself. The observable universe is the things that we can see based on the light that came from them. All right. The great red spot on Jupiter is actually a hurricane. It will dissipate though. It's actually getting smaller. You could reach the star closest to the sun if you travel your entire lifetime. Now with current technology, we'll discuss that in the next couple weeks. All right. There are a couple projects NASA's looking at that might be able to reach the next star. A constellation is a group of stars that we use to name their location. The name of the North Star is currently Polaris, but it will not always be our North Star because Vega will be our North Star in about 12,000 years. The goal of an astronomer is to understand the entirety of the universe, all right, not just planets, not just stars. Through observing shadows of different cities, Eratosthenes used basic geometry to determine that the Earth is spherical, not just round, because if it was round, it could also be flat. Round implies a circle. Sphere implies a 3D circular object. The different elements and atoms come from stars. They get crushed into the core by fusion. However, you need explosions. You need supernova to have other elements fuse into other. You need something stronger than the core of a star, and that would be a star exploding. Okay. Then we found out to get to gold and the other heavier elements in the periodic table, you need something even stronger than a supernova explosion. You need two neutron stars merging together, and that's how you get something like gold, platinum, so on. The higher mass metals. Okay, you need fusion of two entire stars. Neutron stars are the dead cores of very large stars. All right, very dense, high amounts of radiation. We'll talk more about stars, their life cycle in the coming weeks. Our star has a lot of hydrogen, which fuses into helium. 1 + 1 equals atomic number 2. Helium produces a lot of energy. Okay, you can get up to iron inside the core of a star. Light is made up of atoms? No, because it's energy. Unless you're a Harvard researcher and they discover that you can use two particles of light called photons and you can actually have them bond together and you can make a molecule of light. So light can exist in the boundary between matter and energy. Okay, so think of that as like an energy molecule because energy can be mass and mass can be energy. How do we know that? Well, because of my friend Einstein, right? E equals mc squared. Since the show started, how far would light travel from the projector if it traveled in a straight line? Projector, screen, whatever you're looking at. It was 540 million kilometers. All right. How long will it take to get to the nearest star? I'm emphasizing it. If it takes 4.3 light years to get to Proxima Centauri, how many years or how long would it take to get to the nearest star if you could travel the speed of light? I did not add that in there for some reason. Let me put that in. How long would it take to get to the nearest star if you traveled the speed of light? Don't need two L's there. How long will it take to get to the nearest star if you travel the speed of light? All right. So today was kind of a relaxed session, just watching Bill Nye, following along with it, just making sure you're following along with it, answering those questions, because it's going to be a good jumping off point. Whoops. We don't need new, we need Sagan. Good jumping off point for the next unit, which we're going to talk about the solar system. All right. You got any questions, let me know, but hopefully this was pretty straightforward. If you do have any questions, let me know. Again, your scores and unit tests, they'll come back as I grade the ones that I haven't graded today. And then I will then track down those who have not done it. But your scores will be in Thursday or Friday, tomorrow or Friday. Okay? Those of you that were spamming my chat, you're lucky today was a very relaxed day. Let you chill out, all right? Next time, we're doing it for real. We all good? Good. Good job, Rainey. I'll see you guys later. Bye, Azra. Bye, Rainey. No, the Earth is not a torus. Gravity pulls in all directions to the center. Will not make a torus. Our universe, however, may be the shape of a torus, a donut, if it folds in on of itself. Einstein said no. Bye, Eric. Bye, Ryan. Bye, Kaylee. Bye, Downey. Bye, Charlie. And he's a golden retriever, by the way. Germans are good dogs. Nice, Charlie. See you guys.